session today. I'm really happy that you stayed because this is also a very exciting area of research that is going to be presented now in this part of the symposium. And I would like to continue with the second learning objective that we have for the symposium. It's also something that Magnus taught us, and it's to do in any situation where things don't go according to the plan, to behave so as if it was completely part of the plan. But the problem is that you have already all seen the program, and I will not be able to apply this rule. This is probably the only situation in which I cannot apply this rule. So unfortunately, our last speaker, due to an emergency situation, will not be able to join us today. This means we will have two speakers, and afterwards we will join the coffee reception where we can continue our discussion. And with that, I would like to introduce our first speaker of the second session, who is Professor Dr. Vincent Heuveline. He is the Managing Director of the Computing Center and the Chief Information Officer of Heidelberg University. As a professor, he heads the Engineering, Mathematics and Computing Lab at the Interdisciplinary Center for Scientific Computing. He also leads the research group Data Mining and Uncertainty Quantification at the Heidelberg Institute for Theoretical Studies. His research interests include scientific high-performance and data-intensive computing, as well as software development with a particular focus on areas of application in medical technology and energy research, exactly what the doctor ordered. As an educator, expert, and consultant, he deals intensively with the topic of IT security and advises industry representatives on topics such as the application-oriented use of numerical simulations, cloud computing, and IT security in the industrial sector. With that, I would like to welcome Professor Heuveline to the stage. I'm looking forward to your talk.
Thank you very much. So thank you very much for the introduction. Can you hear me? Is that okay? All right? What? So I'm very happy to be here. First of all, I would like to thank you for the introduction and for the invitation. And I'm very, very pleased to be here, also for you, Magnus. And before beginning, and indeed starting with my presentation, where I would like to give some insights on AI, I would like maybe to say some words. The reason why, at some level, I'm here, and a little bit of background, to give a kind of background why a mathematician by training is studying with Magnus to the ATB and possibly some research. Dear Magnus, I was looking a little bit on some quotation you have given, and you have given quite a lot. So having a look in the literature, we can see that with Magnus is very prolific, and indeed giving some insights not only in his own area, but indeed in areas which are related some level to medicine, but to computer science, to innovation. And again, before beginning my presentation, I would like to say some few anecdotes. The first meeting with Magnus was a really long, very impressive discussion we had. We did not know each other very well. And Magnus told me, I'm interested in AI. I'm interested in computer science and mathematics. And I was very impressed by the fact that Magnus could really begin such a discussion, even in a quite profound way. And we then began to discuss what could be mathematical oncology in Germany. It turns out that mathematical oncology is something well known in the state. There are very, very few persons working in that area in Europe. At the first meeting with Magnus, we already planned at some level in the future, and I would say we were quite successful indeed in establishing this area in Europe and developing a kind of business what could be the coupling of mathematics, cancer research, and indeed computer science. It was only the beginning, and my goal today is not to say we are successful, and my goal is to emphasize the very strong influence of Magnus for that kind of discussion because it's very seldom to meet the colleagues just starting from the beginning in a project and indeed in a quite risky research where we knew where I'm starting, but we didn't know exactly where are we, in fact, what are we going to attain, in fact, in the results. And I would say, having a look here, Magnus' background, I think we just managed to think quite impressive and quite the results in this cooperation. And I'm very thankful for that. This is the reason why I'm very happy to be here and to transport also this this way of thinking, which is, to my opinion, truly a research way, innovative way, and coupling indeed areas in mathematics, computer science, but also entrepreneurship, which is quite also impressive. The idea to say if we have ideas, it's not only a question of making research on that, but to see how can we use all these ideas in such a can also go maybe to our products and also have a kind of impact in the economy. And again, I'm very, very thankful, Magnus, for that. Based on that, I would like first, and I think it fits perfectly in this quotation, und somit heißt sich auch die Medizin im Informationszeitalter den Prozess des Umbruchs ein, der durch die Speicherung, Bearbeitung riesige Datenmengen auf einmal wurden. This is what the statement of a computer scientist. This is Magnus. All right? So, based on this statement, I would like to start my presentation. And this presentation is exactly related to this statement and is related to AI. We have currently, obviously, a kind of revelation associated to AI in the medical area. And first of all, I would like to give some simple applications what can be done with AI, and step by step give some applications in medicine, open the subjects, and hopefully give some inspiration of what can be done in that context. What you see here are pictures and images which are completely generated by AI. So, this here, you have being some mathematical lectures is obviously not true. This picture here has been indeed created by what we call a prompt. It means to first write down, please generate an image where I see a beer giving a lecture in mathematics. Writing down that, you apply these pictures. Well, here you can have quite a lot of fun, put a glass on the head of a dog, you just write it down, and it generates this picture. If you have a clear look on that, there are a lot of questions arising behind that, since that kind of technology now is open for everybody. So it means you can generate almost any image based on prompting with a lot of effects based on that. Now, if we continue on the possibilities behind AI, I would like here to emphasize that you can also want to make an editing of the images. Assume you have this beautiful photo, in fact, of the dog, and now you would like, based on this dog, to generate pictures where you have a jumping dog. You can't do that. So this picture and this position of the dog does not exist on its own. It has been completely artificially created. All right? Based on this knowledge. You have a privacy. Privacy is an important topic. This is the reason why you are not seeing the head of the person. And based on this image here, generate any kind of position of the source. I don't want to go into details on the impact on politics and in kind of fake images you can generate on that. And the cat be a kind of symmetry toward the dog you see here. You can, of course, do the same here, with indeed as compared to, in fact, the dog. I think ChatGPT will work heroes for everybody. And I would like to see few words what you can do with that, even in the scientific level. If you assume you would like to have a kind of scientific abstract, you're in a hurry for a conference, please do not do so. Enjoy the next course. It's a kind of ironical statement. But you could ask ChatGPT to write a scientific abstract. Write a research Nature paper about a newly developed method for modeling myocarditis, or use only 100 words. You just ask ChatGPT, it generates this abstract, ask some of the colleagues in cardiology that told me, well, this is the perfect abstract for that. And so here also we have possibilities which are in fact available. We need to see and understand how are we going to handle that. How can we use that kind of technology in a beneficial way? What are the dangers? What are the pros and cons? And this is what I would like to do and to explain in very short in this presentation. I would like to begin with two keywords which are possibly not so well known, which are weak AI and strong AI. So we are speaking about artificial intelligence, künstliche Intelligenz. So we are speaking about intelligence. And as a matter of fact, we need at some level to define what is intelligence at some level. And just looking in that direction, it turns out that this thing is pretty complicated, and obviously we have different levels of understanding what is intelligence. One of the important aspects related to AI is the fact that the current system we have capabilities. Please consider the images I presented at the beginning to generate very beautiful images, but possibly not to stick, not to imagine something, not to have a communication or even social intelligence. And the ability to have specific capabilities. I can generate, in fact, a picture. I can make speech recognition. I can drive a car. All, these abilities are dedicated, let's say, tasks, if I do, and a system able to do one of the tasks is called the weak AI system. Weak says it does not map the capability whereas a zero, we can drive a car, but we can possibly also make a very beautiful painting. All the systems we have today fall in this category of weak AI. And this is, of course, the opposite of what we call strong AI, where indeed you have the ability to almost fit or even surpass, in fact, the capabilities of human intelligence, and in all possible areas. Logical thinking, ability to make decisions, plan, learn, communication, and actually very important humor. Very difficult task for a machine to, in fact, make humor. So you all know, indeed, Terminator, Schwarzenegger, and as a matter of fact, Terminator is a representation of strong AI. I'm not playing with the words, it's often strong, but the AI behind is a strong one, because it's able to indeed cope with all possible areas. If you consider another study, 75% of the German population thinks that AI, that Terminator is a good example of existing AI. And I'm sorry to proceed to deceive you and to break the beautiful picture. This is obviously today not the case. We do not have today systems which are strong AI, which are able to surpass, in fact, and have the same capabilities as human, in fact, in all areas. I need first to go into the technical details, but I will take it short to describe the way this AI system is working. The origin, in fact, of our AI system is, in fact, medicine, because mathematicians try to map at some level the brain. So it was the origin, in fact, of the AI system. And the brain is, of course, full of synapses and, in fact, cells just interconnected. And as a matter of fact, I personally was involved already in research 30 years ago, already for that kind of system. And what we've done is to define such layers, so-called single layer perceptron. It means a very simplified cell being able to communicate with a lot of other cells. And based on that kind of system, check if such a system is able to learn something. And how does it work? We come back to the last slide. It was like that. You expose the system, let's say, with a cat. So it means at the input layer, you show a picture, and you just learn the system that this picture is a cat. You adapt all connection you have in the system in order to obtain this answer. We call that the backwards, in fact, transition. And you do the same for dogs. You expose the system with a lot of dogs. And this system will adapt step by step to see how this is a dog. But what is happening is that based, in fact, on new picture, if you just expose the system in a completely new cat, it turns out that this very, very complicated system will be able to recognize this new cat, which has not been, let's say, learned in the past. So it means you have a learning step based on, in fact, exposing the system to interaction, let's say, to keep it simple, images, and by refining, this system is able to adapt and indeed to detect new pictures and put the right category for that. It seems quite simple because it would tell me that a child is able to do that almost in a much simpler way. But it turns out that indeed the work needed for that is immense and extremely difficult. 30 years ago, for that kind of system, we did not have the machines which were able to compute that. Now, what we have supercomputers who are very, very powerful in this. And by the way, as a small anecdote, we have the so-called GPU, graphic processing units, coming from gaming, not coming from science, by the way. And these graphic processing units are extremely powerful in a computation of that kind, and are indeed a technology development which allows for indeed being able to have very strong learning system. When you have trained a system, then you can use that as a model. Like ChatGPT is nothing else but such a system which has learned a lot of text, not pictures, but text. And based on that, this system is able on its own to generate indeed indeed new text. I would like to separate the small mistake here on my slide, and sorry about that, to describe two different AI, whether what we call discriminative AI and generative AI. Discriminative AI means that the system you have is able to discriminate different actors, in fact, you're considering. For example, if you have a picture like that, we, as a human, we can differentiate what is a car, what is a bicycle, what is a person, which is quite important, of course, if you want to drive a car for us. The machines in the new world is able to discriminate, but it means to really recognize what are the different actors here and to adapt the behavior, in fact, of driving in that way. This is what we consider as discriminated AI, the ability to define different categories. The second aspect you are all very surely already very fond of is generative AI, the GPT. And generative AI means that the AI system is able to generate, to create a completely new entity. What you see here is generative AI. Two cute spiders in Victorian outfits having a miniature tea party with a tiny table and people on the list microphoto. You just write down that and obtain this beautiful 2Q spiders pencil. All right? This is generative AI. Okay? And currently, of course, these systems can be used not only for fun, but for very serious applications. And this is what it will show in the short. Maybe just putting one keyword, which is related to the black box aspect. And this is some aspect we like to emphasize where we still have a lot of research, and I hope we can keep track and contact with Magnus also on that kind of topics. Currently, we have systems which are very powerful, but we partly do not understand how they work. So it means they obtain and just deliver results, but we cannot currently, for many of the systems, tell why do this system are working such well. And this is a problem, because it means that for some specific situation, these systems could have problems, and using that kind of system in medicine is, of course, a huge responsibility. All right? I would like to give examples which are not related to, indeed, the cooperation and the work we have with Magnus, but maybe as a kind of vision, what could be, in fact, the future in that area. And I'm choosing some aspect, in fact, related to surgery. Surgery are, in fact, topics where I need to, indeed, incorporate a lot of data. And one of the aspects you can, of course, use for AI is to use all this data as a kind of assistance, to use AI as a kind of assistant systems in order to be able, in fact, to incorporate the different, in fact, aspects you have and to, let's say, deliver an information which is useful for the surgery, and we say which is going to be patient-dependent, which is then specified, in fact, for utility. This is the kind of scenarios we are able, by the way, till now already to address. As you can see in the surgery, you have the assisting system, and that kind of assisting system are increasingly, indeed, used or based on AI, indeed, system. Due to time restriction, I will switch that. I would like maybe to give some also vision of the future I assume to be available in medical application and related to the hospital. AI is something which can be used, of course, in the administrative processes related to all the hospitals. Since in all cases, in all areas related, for example, to prevention, you have a huge amount of data to analyze. This kind of system are very well suited for that. Diagnostics, this is quite obvious. Here also a question of data, how to handle that, how to derive, in fact, some fact about public health, many aspects related to that, and therapeutics. So I assume in the future that all aspects around AI will find are going to already to find their place, in fact, in that context. And in order to handle that, I would like to emphasize, and this is one of my last slide, how many minutes I have? 5 minutes? All right, I keep it short. I would like to emphasize the fact that all aspects related to AI are also related to infrastructure. And you will need, and this is a picture in this picture here, you need a lot of compute power in order to be able to handle this data. So you need a very strong infrastructure. And you need expertise. So you need here people, because if the students, new researcher, learning and being able to learn that. And now I would like to come back to Magnus. I know that in the spirit of Magnus, all aspects related to research are not only dedicated to your own subject in cancer research, but also with these different aspects. Infrastructure means, at some level, money and funding. So you need to have partners being able to leverage your potential, in fact, be needed there. But we need also to have young talents which you are able to understand and also to leverage, in fact, this technology. And I based on my interaction with Magnus, I know that you are promoting this different level very, very strongly. And I would like to emphasize that. Since at the end of this presentation, I would like maybe to give some pro and contrast so that this talk is not, let's say, we will see everything will be solved with AI. I think we need to find the right balance. What are, in fact, the advantages and disadvantages? I think that the opportunities are clearly improving healthcare, improving the understanding, in fact, of the data. We have a lot of data, and we are not using usually this data. So there is a big deal here. Promoting education and teaching, I think this is also very important because based on AI, you are able to define in these scenarios, indeed, where this all, in fact, this information can be used optimization of many work processes. I think AI is very well suited for that. We, however, need to be very careful on issues related to data protection and security. Seeing all this data, in fact, have a value, and of course, the misuse, and there is, in fact, a big aspect here. Labor market, I think, this is also job market, very important, and also social inequality. One need to be careful on that, but we do not have going to other society where only some people are able to access to this technology and others not. And I think there is here a big deal behind what. I would like to put only some personal thoughts on that to go in the discussion, that maybe to finalize my presentation on some statements back to you, Marcus. I would like really to emphasize that we truly need people like Magnus, just putting interdisciplinary work in different areas, just, I would say, breaking the doors between the different, communities we have. And maybe if I may do so, also in my responsibility as CIO of Heidelberg University, I hope ATB to be also an institution continuing on the path you have already, in fact, developed. I know Matthias, I don't know where he is. Matthias is already, continuing on this path, and I hope this mindset, you have established, Magnus, we can perpetuate, in fact, in the future. Thank you very much. As I said.